I'm trying to make sure this is close to what's on the. I want to know what is the acceleration of the particle at t equals 2. What is acceleration? How do I find acceleration?
Double derivative. Or wait, just, I guess this is false.
Derivative and plug in 2.
Is that
What
a
is,
2 plus?
yes. What is the derivative of this?
0. Let's see. 6 times 1.3, or is that 0.6?
Is it, isn't the derivative of this 0?
Yes.
Yeah.
So it is 1.3, negative 1.3 sine of 0.6t times 0.6.
What was the question?
Find acceleration at 2. Is that the right derivative?
So it's negative 7.
Griffin, you can't do that in your head. Make sure you're in radian mode.
Oh, yeah. Ooh, good call. I forgot.
I'm close. Negative 7 point, or negative 0.72.
Okay, first of all, it's got to be 3 decimal places if it goes.
Negative 0.727.
Do you agree? Okay.
Wait.
Why is acceleration negative?
Because it's switched down backwards.
It's not slowing down, it's going backwards, right?
Wait.
Slowing down is when velocity and acceleration are the same. Or opposite, right? Speeding up when they're the same, slowing down when they're opposite. So the negative just tells us what it's doing. It doesn't mean that it's...
Wait, negative acceleration is going backwards?
Yeah. Go.
What'd you say acceleration was?
Negative
7.727.
727?
Yeah.
Doesn't that mean it's just decelerating?
No.
It's just the way it works.
Math is good. Yeah.
Okay. If I give you this equation, I want to know, when is this particle at rest?
So is that t, and we find the derivative is that t equals 0?
Why do you find the derivative?
Because that velocity goes 0.
Because it is at rest when the velocity is 0. Right?
Mm-hmm.
So find the velocity and set it equal to 0.
Mm-hmm.
Tell me when it is at rest. Why would we do a quotient rule? What's a quotient? Is this right here 1/3 t cubed?
Yes.
You guys have to know that.
Yeah. Sure do. Completely right there. Yeah, that.
Woo.
Man.
1/6.
Negative 1/6?
Yeah. Maybe in Lucas for people.
The whole world.
Okay, what if I ask you, for what time is it at rest? Would that make a difference? What time is it at rest?
No, it wouldn't.
Yes, it would, because I can't have a negative time.
Oh, so 6.
So 6. Understand the difference?
Wait, what was the first question?
When is it at rest? But then I said, at what time is it at rest? Time has to be a positive number. Time can't give me a negative time. This isn't the Back to the Future or whatever.
Okay, so good answer. 6.
6?
And I'm sorry, where'd you say the period was?
6 and negative 1 for the first.
I didn't. I said it was time, and time has to be positive.
Right, okay.
Wait, so what is the difference? What are you asking for when you say when?
Well, if you want to know when something is at rest, you're talking about time, aren't you?
Yeah.
If I say when, doesn't that mean what time?
Yeah.
Right? Time can't be negative.
So then why do we get the negative for the first one?
I don't know. Why did you?
Threw mine away that one that she said it was valid.
I want f prime of pi over 3. How do I find f prime? Is that a product?
Yeah, it sure is. 100%.
Good, take the derivative. Doesn't this means take the derivative and plug in pi over 3? We all agree with that?
Why do you multiply it by 3?
Derivative of the inside?
Oh. Oh, wow. Yeah, the thing, outside shell.
M&M.
That makes
It's
sense.
an M&M. Isn't it?
Yeah, sure is.
Wait, where'd you? Okay, so there's the M&M that first apart there. You got the negative sign 3x3. But why'd you put the 2x cosine back in?
I did the product rule. First times derivative of the second plus second times the derivative of the first. So, this is what I think I have. Negative 3 pi squared over 9 What's sine of pi? Times 0 plus 2 pi over 3. What's the cosine of pi?
1/2.
Negative 1.
I thought we were plugging in pi over 3.
We are.
Maybe that.
Pi over
I
3
did.
times 3 is
Pi.
Wait, so we actually don't plug in the pi until we find the derivative.
Yes.
Where'd you get the negative from?
Negative.
Oh, it's that. Wait,
And then
is that your?
squared
Uh-huh.
That's your 3 for the negative sign. Okay.
Am I right, Jensen?
Well, I know. Pi over 3.
So the answer is negative 2 pi over 3.
Confused what you got first. That negative 3 pi over 9 squared.
I put pi over 3 in here. Okay, I have a 3 here and negative here. I brought them out front. In place of x, I put pi over 3.
How did you get 1 for that? How did you get 1 for cosine 3x?
I didn't. I got negative 1.
How did you get negative?
What is what is 3x times pi over 3? What is 3 times pi over 3?
Pi?
What's the cosine of pi? Negative 1. Are we in agreement?
Yeah.
Are they boring?
No, I was understanding.
I still don't know where the 9.
Why do you understand?
Where what came from?
Yes.
The 9 on the bottom, right here. Because I put pi over 3 in for x. That means you square the top, square the bottom. Pi squared over 9.
Oh, okay.
Come on, Ben, hurry up. Jensen understands this.
I don't know. She's very small.
So the 3, the negative 3 came from that 1 3.
And then you pull out the negatives.
Okay.
Did y'all write this one down? Can I make a suggestion that we go back over it before tomorrow?
Yes.
I need to go over that.
How do you know? What does a function have to be to have a derivative? Do you remember we said a function cannot have a derivative anywhere it has a cusp or a corner? So if I give you a function that looks like this, I'll let this be 1, this be 2. Okay, are you all going to do this or not? Because you know what, I don't need the review. Which x value is the function continuous but not differentiable?
Continuous with e at 2, 1.
1. Because why?
It doesn't
Because
stop.
it's a cusp.
There's
Remember at a cusp, you can't take the derivative? Do you remember that?
The differential means you can take the derivative.
Uh-huh. Luke, would you knock his hands off, please?
Luke's the slapper guy. He always slaps.
Do you know the product rule?
Yes.
Do you know the quotient rule?
How do you do this? Wait. Product rule?
What?
How about not maybe that's the
I'm trying to make sure I'm covering everything here.
Jensen knows it. Jensen's gonna get one of those test on his phone.
I want to know where this has horizontal tangents.
Horizontal tangents is when x equals 0.
No,
No, when y equals 0.
no. Where does it have, what does horizontal tangent mean?
Like this.
Thank you.
slow.
Which is the slope or derivative.
So we find the derivative
Are
and
you
set
with
that
us now?
equals 0. So it's
Are you
2x
bored?
minus 6.
I mean, we didn't do any of this in ours.
So what is the slope?
It's
3. Move.
You guys can find
2x minus 6.
And what do I do with that?
You do x equals negative 3, or x equals 3.
Set it equal to 0, solve for x. X is 3. So if it asks, find all points where it has a horizontal tangent. Doesn't it have a horizontal tangent when x is 3? That is not a point. How do I find a point?
Bring it back in.
Huh?
Y.
You plug it back in.
Okay. So what point is there a horizontal tangent?
9 and minus.
So is that 3
Okay.
negative 9?
What?
So that's 0.3 negative
Oh,
9.
no.
Or is that 3 2 negative 9?
That is the point.
Let's have fun. Can we do one where we have to how to find the slope of the tangent line? Because those are always
Okay.
Okay.
We're going to find the slope, or excuse me, the equation of the tangent and normal line. I don't think that's right. Yep, I think that's right. I want the slope of the first, I want the slope, or I want the equation of the tangent line.
So are we given 1, 0?
Yes, that is your point. At that point, what is the tangent line? What? Did you do that first?
I sure did. I got it down now.
It's pretty awesome.
Downtown all around.
You got it, bro. Yep. Oh, wait a minute.
Is that right?
Wait.
why did we have to do that?
I take the derivative.
No, I know, but why do we have to put them back to each other?
You didn't. I just think it's easier to put a number in if I do.
Why is it?
-6?
Why is it?
What did you plug in to get it out?
Is that what you got?
Yes.
So 1.
Plug 1 in.
1 over 1.
How do I get slope? There's my tangent line.
Nice.
Guys, to find the normal line, I cannot just take this line and turn over the slope.
Yeah.
Some of you seem to want to. How do I find the normal line.
Y minus 0 equals 1/6 times x minus 1.
Nice.
Right? So y equals 1/6 x minus 1/6.
Mm-hmm.
Yeah.
Are we good with that?
Good. Scary place.
What's the derivative? Differentiate this.
Differentiate. Okay, that makes more sense.
Are you doing a quotient? Did you already do it? So what you get?
Negative 16x.
Negative 16x over x squared minus 4? Squared, okay. Do we agree? So we've got the quotient rule now. Apparently not.
Baby though, minus one baby.
Oh, that's, I think that minus multiplier.
All right.
Got it. All new positions now. Yay. I like how I now instantly see S in position.
My question is, when is the particle moving to the right?
Are we going to have to do one entire, like, find
I do. My question is, where's it? Well, you're going to have to.
You're going to have to know how to do them all, but are you going to have to all the pieces or just a few?
Just a few. What am I going to do? Take the derivative. Thank you. And what is the derivative? Velocity.
E minus 2.
Right? When is that 0? Oh, I probably should give you. Do I give you an interval? Huh?
Not squared.
Oh, not squared. Thank you. What is the? Where did you get it to be 0? Let's do this interval.
Is that going to be given or we?
Yes. So aren't I doing 0 to what?
1.5.
No. Right? What do I do with that? Okay. So I believe it's this. It won't matter.
Is that where if we just calculated or we traced it?
So where's it going to the right? 1.549 to 4? Don't tell me where it's plus and minus. When is it speeding up? So what is acceleration? 12t minus 8, right?
And they're both plus, so it's speeding up from 1.549 to 4, and then it slows down from 0 to 1.549. Okay, we did that like this.
Acceleration, what did we find? What,
They're both plus.
2/3? So that's about right here. And so we had 0 to 2/3, 2/3 to 4.
It's always
1/3.
It's always a plus. I think this is a minus.
Yeah.
no, this is less than 1 thing.
So where is it speeding up?
So from 1.549 to 4, 0 to 2/3.
It's speeding up here, and it's speeding up here, right?
Yeah.
You all know how to do that? Now,
You want to spread it out, it's speeding up to 2/3. 2/3 to 1.5, I did 4.
uh-huh.
I remember this.
This is fun.
What is the total distance traveled?
Oh,
Don't I want f sub 0, f sub 1 point, oops,
Whoa.
0,
1.5, I think.
1.549, and s sub 4. And here's s. You all have a calculator. Somebody give me the values. S sub 0 is easy. It's 5.
So slow.
Negative 2.897.
Negative 2.897.
That's what I said.
What is s sub 4? What? 61.
Here we go.
So I think the distance from 5 to here is like, what, 7.897?
Yeah.
Huh?
Yeah.
7.897? Plus what? 7.897 plus 63?
Wait. How did you get 60?
You did?
63.8.
897? Yeah.
I got that.
How far is it from negative 2.897 to 61?
61 plus 0.26.
Did you get different numbers?
Hold on.
I got 0.2.
I got negative 0.262.
Now I can see 1.6.
Oh, for
Yeah.
this one?
Yeah, I got negative
Good job,
0.262.
guys.
Negative point what?
262.
262.
The other ones I got the same.
Okay. So my numbers are off, right?
And negative.
I should be at, instead of adding this,
Should be 5.262.
plus what? 61.262?
Yeah. Okay.
66.524?
Yeah.
Ms. Paul, I'm not understanding where you're getting the 5 and the 61. I'm to the point where I plug in the things into our S and then
Okay.
I don't understand.
How far is it from 5 to here?
Okay, so that's,
5.262, isn't it?
yeah,
That's how I got that first number. How far is it from here to here?
so from the negative 0.262 to 61.
How far is it? 61.262? That's where I got those two numbers. I saved the best for last.
Yeah. What is it? Is it the one where I think water's flowing out of that thing?
No,
I didn't do that.
best for last, I think it's the,
This is with no calculator. By the way.
it's like pink stuff.
Using the definition of derivative, find the derivative.
We can look up,
You don't get to look it up. You have to know it.
Dictionary.
What is
Wasn't it the limit
What's it, Jensen?
as h approaches 0
What limits?
of f of x plus h minus f of x all over h?
Why are we using this thing? Why can't I just do
Because
this?
you're expected to know this thing.
So,
Frank, Xavier, and Harrison.
Now, I will tell you that if you do not have the limit as h approaches 0, it is wrong.
Making our final answer.
In your answer, in your problem where you're working it. Because you have to state that you're going to put 0 in for h. You can't just plug it in. All right. Isn't this x plus h squared minus 4 times x plus h minus x squared minus 4x all over h?
If you know what the derivative's going to be, so you can check your answer.
That's true.
Nice.
However, you'd be surprised how many students I have miss it. I'm like, you didn't even check your answer to know you messed up somewhere?
Amen.
Do you agree with what I've done?
Yes, I do.
maybe.
Luke?
We put the elimination thing for every single part.
No, but you better have it at least once.
So why isn't it after the 4, why is it x plus
It should be x plus h. Thank you.
Just want to make sure. Yeah. Okay.
all motions are approved?
Guys. So, do I just FOIL this out now? I have x squared plus 2xh plus h squared minus 4x minus 4h minus x squared plus 4x all over h.
Let's, combine like terms. And
So, do the x squared subtract out?
plus x minus 4x.
4x is,
And the,
Now we just take out an h.
take out an h,
now,
and I'm left,
And you got 2x, or h plus 2x.
I have 2x
x
plus h minus 4 over h.
So plug
bang.
cancel.
And plug in
2x
0.
minus 4.
Plug in 0 for h,
2x minus 4.
and I have 2x minus 4. Is that what it should have been?
My gosh, it's so annoying. You could have do like
Oh,
3 seconds.
I forgot that. Wait, can you scroll it?
Yeah.
That's so.
Up or
that's
down,
so
you at the
bad.
bottom?
I just have to write the
Why
answer
do they
down there
have
and
to
drop
write
random numbers on.
Okay, if you just happen to write the answer, I'm just going to happen to count it wrong.
Do we have points?
No. If there's no word, there is
What
no
if there is
word.
words, but like you messed
No
up?
word, no
We still
perk.
get the answer.
Well, if you know the answer, you ought to be able to fix your work to make it work.
Amen.
So what was like the initial question? Yeah.
Find the derivative using the definition of derivative.
What is it?